Hi dear students, welcome back to computer science class. We have already completed stack in detail, the data structure stack in detail, the theory, the operations as well as implementation in detail, right? So today we have another very important data structure, Q for discussion, and we know Q is another linear data structure, like it's like a stack. It follows linear, right? Or it contains sequence of items, or it's a sequential data item or sequential data structure, right? And let's compare and study, right? Stack and queue. We know in stack we have only one opening, and through that opening we are performing both insertion and deletion. But here in queue, the concept is taken from the actual real world, the real world queue, right? So there we have two ends, and through one end we are performing insertion, through the other end we are performing deletion. Meaning in queue we have two opponents, front and rear, right? Front and rear, and through one end we are performing insertion, through the other end we are performing deletion, right? So that's the main difference between stack and queue. And let's define queue specifically, right? Okay, queue is a linear data structure, that's the first point. And in here insertion is performed through one end, that end is called rear end, the back end, and deletion is performed through another end, that end is called front end of the queue, right? And insertion operation is known as push, deletion is known as pop, and the information processing order is FIFO, first in first out, or we can say what, first come first served. First input that item can be taken out first, that's what a queue is, right? Yes. So it's a sequence of items, or it's a linear data structure like a stack. Then insertion performed at one end, that end is called rear end of the queue, and deletion performed at the other end, that end is called front end of the queue. And some of the examples, some of the real-time examples: bank, ATM, fee counter, shopping center. And here in computer science, another one example is print to queue, right? Print to queue, and always performs many of its functions based on queue, just like a stack. Okay, yeah, we're coming to it. Then the processing order here in queue is FIFO, first in first out, or we can say first come first served. Those who come first will be served first, that's it. Okay, yeah. And here is a queue with how many elements? 4 elements, right? 4 elements. We know we implementing queue as a list. We know list is a dynamic data structure which contain heterogeneous elements, which can contain heterogeneous elements, right? Yes. So here we have a list. We implementing the concept of queue as a list. Yes. Here we have a list implemented as a queue with 4 elements. We have one more space here. Okay. Then you can see the index 0, 1, 2, 3, 4. Yes. Then you can see the ends, front end and rear end. And we are performing deletion through front end and insertion through rear end. Just like this, we are deleting through this end, then we are inserting through this end, and the end through which we perform insertion is called rear end, and deletion through front end, right? Yes. Then queue has 2 opponents, right? In the case of stack we have only one opponent, the other end is closed, and the opponent is called top of the stack. But here in queue we have 2 opponents, front and rear. Through front we are performing deletion, through rear we are performing insertion. Then queue as a list, we are implementing queue as a list. When we create queue as a list, both rear and front points to 0, or the value of both rear and front will be 0. It indicates an empty queue or an empty list. Okay, yes, meaning initially both front and rear points to 0. It shows an empty queue. Okay, yes, queue always contains heterogeneous elements as we implement queue as a list, because list is a dynamic data structure as well as it contains heterogeneous elements. So queue is also a heterogeneous data type, right? Or queue can hold heterogeneous elements, elements of different types. So this is all about the theory part of queue. We know. Let's look at a queue in detail. Okay, at fast. Okay, yes. Queue means a queue is a linear data structure or a sequential data structure. It contains the operations. Okay, yes. It's a sequential data structure or it's a linear data structure. Then insertion through one end called rear, deletion through another end called front. Then insertion is called push, deletion is called pop. Okay. Then information processing order is first in first out, or first come first serve. And here we have an example showing front, rear, through front, we are performing deletion through this and insertion through this and rear. Okay, index 0, 1, 2, 3, 4, and we implement this the concept of queue as a list. Okay, we have two operands, front and rear. Queue as a list. Initially, front and rear points to 0. It shows an empty queue. Okay, then it contains heterogeneous elements as we implement the concept of queue as a list. Okay, so this is all for the theory part of queue. Next, we are looking at operations which can be performed on a queue. Thank you for watching.